The next type of variation that we're going to look at is a little bit unusual and possibly the first time you're seeing something quite like this. And it's the idea of joint variation. So, for example, the amount of water that can be stored in a conical tank varies directly with the area of the base and the height of the tank. Makes sense, right? If the tank gets taller, it can hold more water, or if the base gets larger, it could also hold more water. So a conical tank with a base area of 40.26 square feet and a height of 4 feet can hold 401.6 gallons of water. Now I'll refer you to the definition of joint variation on the next page of the notes that says that as y varies jointly with x and z, we have something like y equals k times x times z, where x, z, and y can all vary. Now in this case, we're told that the amount of water, we could call that A, that can be stored in a conical tank varies directly with the area of the base and the height of the tank. Now a convention of geometry is to have areas represented as, areas and volumes I should say, represented using capital letters. So if we let capital B represent the area of the base, we'll let H represent the height of the tank. Now that means that we can write our equation as y, oh, just kidding, we're not using y, we're using A, B, and H. So A, the area, varies jointly with the area of the base, sorry, A, the amount of water, not the area, times the height of the tank. And again, that is A, the amount of water, varies jointly with B, the area of the base, and H, the height of the tank. Now, we're not quite done. We still need to find the constant of variation, but we're told some additional information. We're told that the tank that has a base of 40.26 square feet, so if B equals 40.26, and I'll omit the units here for space considerations, and a height of 4 feet, then we'll get an area, or a volume, of, an amount of 401.6. So if we put all of that together, we see that 401.6 is equal to K times the base volume, or the area, 40.26, times the height, 4. Now solving this for K, we find that K is equal to 2.494. So our model, and I'll write this on in the next space, we could say A is equal to 2.494 times capital B times H. Now in the next part we're asked if the conical tank has a base area of 86.59 square feet, in other words, if B is equal to 86.59, and the tank is able to hold 1,511 gallons. In other words, if A is equal to 1,511, we want to know how tall does the tank need to be. Now we have a model. We have an equation involving A, B, and H. So let's plug in what we know and see what we're left with. So if A is 1511, and we have 2.494 times the base, 86.59, times the height. Now we have an equation involving nothing but a bunch of numbers and h. So if I divide out everything that isn't h, we can see that h would have to be 6.99 feet. In other words, h, since we want to round, should be 7. So this is another case where we have derived a model, figured out the variation, or the constant of variation, and taken that model, used it to look at a new situation where we hold all but one thing constant. We'll see something similar in the next problem.